The morning air is cold and damp. Somewhere in Normandy, June 1944, inside a Sherman tank, the engine vibrates through steel plates and bone. Condensation clings to the periscope glass. The smell of fuel, oil, and sweat hangs low in the cramped interior. Outside, hedgerows block the horizon, thick walls of earthen roots hiding what waits beyond. The gunner's eyes stay forward. The driver listens to the engine. The commander leans slightly toward the radio. Then the crackle comes alive. A calm voice cuts through the static short, precise, practiced. Grid references. Enemy movement. An artillery battery adjusting fire 2 miles away. Infantry calling for armor support. Another Sherman platoon reporting contact. Already maneuvering. No hand signals. No runners. No delay. The tank does not advance alone. It moves as part of something larger, an invisible web stretching across fields, villages, and command posts. Orders flow in seconds. Adjustments happen in moments. The battlefield shifts faster than the enemy expects. German anti-tank guns wait for a frontal duel. They will not get one, because this fight is no longer decided by armor thickness or gun caliber alone. It is decided by who can see, speak, and act first. And long before this morning, one side made that choice deliberately. That decision was forged years earlier, before Normandy, before the Sherman ever reached Europe. When the world judged tanks by steel and underestimated the power of the voice inside them, in the years before the Second World War, tanks were judged by simple measurements: armor, thickness, gun caliber, silhouette, speed on paper. Every major power entered the war believing that armored combat would be decided by head-to-head clashes, steel against steel, gun against gun. Whoever fielded the strongest tank, the thinking went, would dominate the battlefield. Germany embraced this logic early. The Panzer arm was designed around precision, discipline, and tactical excellence. German officers emphasized penetration values and engagement ranges. Their doctrine rewarded carefully planned attacks, strong armor protection, and decisive blows delivered at the point of contact. Radios exist, but they were viewed as tools for command tanks and senior leaders, valuable but limited and often scarce. When German crews encountered early Allied armor in Poland, France, and the opening campaigns of the war, this belief seemed correct. Many enemy tanks were poorly coordinated, badly deployed, or slow to react. The German conclusion was reinforced. Battlefield dominance came from superior machines, commanded by elite formations. Across the Atlantic, the United States was watching closely but drawing different lessons. America entered the war later. With no recent experience of large-scale armored combat in Europe, its planners understood that they were unlikely to outmatch Germany tank for tank in the short term. Instead, American doctrine leaned toward mass production, reliability, ease of maintenance, and operational flexibility. The M4 Sherman was the result. On paper, it looked unremarkable. Its armor was thinner than that of later German tanks. Its mine gun, especially in early variants, struggled against heavier German armor at long range. Its tall profile made it easier to spot. German crews quickly noticed these weaknesses, and word spread that the Sherman was inferior, adequate at best, vulnerable at worst. Early encounters appeared to confirm this judgment. In North Africa and Italy, Shermans were knocked out by well-placed anti-tank guns and heavier panzers. German reports focused on kill ratios, armor penetration, and technical superiority. The conclusion seemed obvious, but this analysis missed something critical. The Americans were not building a tank to win isolated duels. They were building a tank to function inside a system, one that emphasized coordination between armor, infantry, artillery, engineers, and air power. The Sherman was never meant to fight alone. Yet German commanders, shaped by their own early successes, continued to evaluate it as if it would. They compared steel to steel, gun to gun, and in doing so, they overlooked the environment the Sherman was designed for, an environment where speed of decision mattered as much as firepower, and where communication would determine who controlled the tempo of the fight. Because while Germany focused on perfecting individual machines, The United States was quietly standardizing something far less visible but far more decisive, and it was already bolted inside every Sherman rolling off the assembly line. By the time the first Shermans reached the battlefield, the United States Army had already made a quiet but decisive choice about how it intended to fight the war. Communication would not be a luxury. It would be standard equipment. American planners understood that modern warfare was no longer linear. Front lines shifted quickly. Units advanced, stalled, and redirected under fire. Without reliable communication, even the most powerful weapon could become isolated and ineffective. Radios, therefore, were not treated as specialist tools reserved for senior officers. They were treated as necessities, issued broadly, trained thoroughly, and integrated into doctrine from the lowest level upward. Every Sherman carried a radio, not just command tanks, not just platoon leaders. Every vehicle. This decision shaped everything that followed. Sherman crews were trained to operate as part of a constant information flow. Tank commanders learned to listen as much as they spoke, monitoring multiple channels, relaying sightings, requesting support, adjusting movements in real time. Infantry units advanced knowing armor could be summoned within minutes. Artillery observers relied on tanks to mark targets. Fighter bombers were directed by voices on the ground, not guesswork from the air. The American Army invested heavily in standardized radio models, spare parts, and maintenance procedures. Sets were ruggedized for dust, vibration, and moisture. Crews were drilled until radio discipline became instinctive. Short transmissions, clear phrasing, immediate acknowledgement. In contrast, German armored units treated radios differently. While early Panzer units had benefited from radio coordination, wartime attrition and industrial strain changed the picture. By the middle years of the war, many German tanks lacked full radio capability. Some vehicles could receive, but not transmit. Others relied on flags or hand signals. Command tanks carried radios, but the farther orders had to travel, the slower they became. This asymmetry mattered. An American tank platoon could reposition within minutes, based on fresh intelligence. A German unit often needed time to relay orders up the chain, time to issue instructions back down, time that the battlefield did not always allow. The result was a fundamental difference in tempo. Sherman units did not need perfect information. They needed enough information, quickly. They could adapt mid-movement, coordinate across terrain, and respond to unexpected threats without stopping to reassemble or wait for messengers. The Sherman became more than a vehicle. It became a node, a moving command post, a sensor, a communicator, a weapon linked to others like it, spreading across the battlefield in coordinated motion. German commanders continued to judge the Sherman by armor thickness and gun caliber, but increasingly they found themselves fighting something harder to measure: an enemy that reacted faster than expected, shifted unexpectedly, and seemed to be everywhere at once. And it was this difference between isolated strength and connected force that would define how the Sherman was truly used in combat. To understand how that advantage played out under fire, the story must now turn from doctrine to experience, from planning rooms to the men inside the tanks. For the men inside a Sherman, the radio was not abstract doctrine. It was presence. In the cramped interior, surrounded by steel and noise, the outside world existed almost entirely through sound. Voices crackled through headsets, familiar tones, unit call signs, clipped urgency. The commander learned to identify fellow tank leaders, not by sight, but by voice. A single transmission could confirm safety, signal danger, or change an entire plan. This constant connection reduced isolation. Crews knew they were not alone, even when visibility dropped to a few yards or smoke swallowed the battlefield. Information flowed laterally between tanks, not just vertically from higher command. A Sherman encountering resistance could warn others instantly. A mistake made by one crew did not have to be repeated by the rest. Confidence followed communication. Crews fought knowing that help artillery, infantry, or neighboring armor was always one transmission away. Radio-equipped Shermans rarely fought static battles. Their strength lay in movement. Platoons maneuvered while staying in constant contact. adjusting formations as terrain and enemy fire dictated. If a tank was disabled, others shifted without waiting for orders. If resistance stiffened, commanders redirected fire, called for smoke, or requested support while still advancing. This flexibility confused German defenders. Anti-tank guns were sighted to cover expected approaches, not rapidly changing axes of advance. By the time German crews identified the main threat, Shermans were already repositioning, guided by radio updates from tanks that had scouted ahead. The battlefield became fluid. Decisions were made at the point of contact, not delayed by rigid command chains. American doctrine trusted junior leaders to act. Tank commanders were empowered to make immediate decisions based on what they saw and heard. Radios allowed platoon leaders and even individual tank commanders to coordinate directly with infantry officers, artillery observers, and engineers. This decentralization mattered under fire. When unexpected obstacles appeared, mines, wreckage, ambush solutions came quickly. A Sherman commander did not wait for approval to request smoke or shift position. He acted, reported, and adjusted as the situation evolved. Leadership became responsive rather than rigid. And as these voices crisscrossed the battlefield, the advantage of connection became increasingly clear, not just to the Americans using it, but to the enemy facing it, because from the German perspective, something was going wrong. Orders were arriving too late. Threats appeared where none had been expected. American armor seemed to anticipate movements before they happened. To understand that frustration, the lens must now shift to the other side of the fight. To German crews, the problem was not just the Sherman tank. It was how it behaved. German anti-tank gunners expected predictable advances. Armor would appear, probe forward, halt under fire, and commit in force. Instead, American tanks shifted rapidly. One Sherman would draw attention, 10 with another would appear from an unexpected angle. Minutes later, artillery fire followed, almost immediately accurate, timed, and persistent. German reports increasingly described American armor as well-coordinated, even when individual Shermans were technically inferior. Panzer commanders complained that U.S. tanks seemed to react instantly, as if guided by a single intelligence. In reality, they were reacting to voices, dozens of them linking units across terrain and time. Without equivalent communication at the lower levels, German responses lagged. By the time orders filtered through the chain of command, the situation had already changed. The radio inside the Sherman was not advanced by later standards. It did not need to be. Its power came from ubiquity and reliability. Because every tank had one, American commanders assumed communication would work and planned accordingly. Artillery schedules, infantry advances, and armored thrusts were synchronized around that assumption. This turned ordinary actions into combined arms effects. A Sherman spotting an enemy gun could trigger artillery fire within minutes. Infantry encountering resistance could pull armor forward without exposing runners or signals. Air support could be redirected in real time. Technology multiplied force, not by complexity, but by consistency. For American crews, constant communication built assurance. Silence was rare. Information flowed, even under fire. Losses were reported immediately. Adjustments followed quickly. For German crews, isolation was more common. A disabled radio could sever a tank from the fight. A platoon might not know what neighboring units were doing or if they still existed. This uncertainty weighed heavily under combat stress. Morale shifted subtly but decisively. One side felt supported by an unseen network. The other felt increasingly alone inside steel halls. By the time major engagements unfolded in Western Europe, this difference was no longer theoretical. It was shaping outcomes. And there would come moments-specific battles, specific hours, when the cumulative effect of communication would push the fight past a point of recovery. That moment was approaching. By the summer of 1944, the difference in communication was no longer subtle. It was decisive. In Normandy, American armored units faced terrain that favored the defender. Hydros broke the landscape into narrow compartments. Visibility was limited. German anti-tank guns were carefully concealed, positioned to kill at close range. On paper, this environment should have punished the Sherman. Instead, it exposed something else. As U.S. forces pushed inland from the beaches, Sherman platoons advanced cautiously but never blindly. Tank commanders spoke constantly with infantry leaders moving through the hedgerows ahead of them. When resistance was encountered, reports moved instantly up and across the net. Within minutes, artillery fire adjusted. Smoke screens appeared. Tanks shifted axes of advance, probing for weak points without committing the entire formation. German defenders noticed the change almost immediately. American tanks no longer blundered forward into prepared killing zones. They halted just outside effective range, relayed grid coordinates, and let indirect fire do the work. If a gun survived, Shermans maneuvered around it, guided by updates from neighboring units. Infantry and armor moved together not by prearranged plan, but by continuous conversation. At the German command level, this tempo was difficult to counter. Orders took time. Messages traveled unevenly. Units often responded to situations that had already passed. As the days wore on, American armored columns began to move faster than German repositioning could keep pace with. Breakthroughs were exploited immediately. A gap identified at noon could be widened by mid. By evening, Shermans were directing traffic through territory that had been contested hours earlier. The battlefield no longer paused between engagements. It flowed. And as that flow accelerated, Sherman doctrine, designed for controlled, deliberate actions, began to fracture under the pressure. This was not the result of a single tank outperforming another. It was the result of hundreds of small decisions made quickly, coordinated by voices that never stopped moving. The turning point was not marked by a single explosion or famous duel. It was marked by momentum. And once momentum shifted, it did not return. But the full impact of that shift would only become clear when American forces finally broke free of the hedgerows, and German command structures collapsed under the speed of what followed. When the breakout came, it came all at once. By late July 1944, American commanders had learned how to fight the hedgerows and, more importantly, how to move beyond them. Operation Cobra began with overwhelming air and artillery preparation. But it was what followed that revealed the full effect of radio-coordinated armor. As the bombardment lifted, Sherman units surged forward not in rigid lines, but in flexible columns. Tank commanders stayed in constant contact with each other and with higher headquarters, reporting resistance, bypassing strong points, and exploiting weak ground the moment it was identified. German defenses, already strained, could not recover fast enough. Panzer units attempted counterattacks, but coordination broke down almost immediately. Orders arrived late or incomplete. Units moved without knowing where neighboring formations were positioned. American Shermans, meanwhile, adjusted routes on the move, redirecting columns around threats before contact was even made. Artillery followed the armor like a shadow. Forward observers rode in tanks, transmitting corrections in real time. Enemy concentrations were hit before they could assemble. When German armor appeared, it rarely found a single Sherman weight. It found a coordinated response, drawing it into kill zones shaped by combined arms. As the breakout widened, speed became the decisive weapon. Sherman columns covered ground faster than German command staffs could process events. Bridges were seized before demolition orders arrived. Road junctions fell before defensive plans could be issued. Entire units found themselves cut off not by superior armor, but by superior awareness. Within days, the German front in Normandy disintegrated. The collapse was not total annihilation, but loss of control. Units still fought, still killed Shermans, still resisted, but no longer as part of a coherent system. The Americans had achieved operational dominance. The Sherman, long dismissed as an inferior tank, had become the visible symbol of that dominance, not because it was unstoppable, but because it was never isolated. It spoke, listened, and acted as part of a constantly adapting network. And once that network broke the enemy's ability to respond in time, the outcome of the campaign was decided. What followed was not immediate victory but irreversible consequence. The battlefield quieted unevenly. In the weeks after the Normandy breakout, the evidence of what had happened lay scattered across roads and fields. Burned out vehicles, abandoned equipment, half-finished defensive positions. German units had not been destroyed outright. Many had escaped, but they had lost something more difficult to replace. They had lost coherence. German after-action reports from the summer of 1944 reveal a recurring theme. American forces moved faster than expected, coordinated attacks more efficiently than anticipated, and recovered from setbacks with unsettling speed. Tactical victories knocking out Shermans. Delaying advances no longer translated into operational success. The enemy adapted too quickly. American losses were real. Shermans continued to burn when hit. Crews were killed. The tank's technical vulnerabilities never disappeared. But these losses did not halt the advance. Units absorbed them, reported team, and adjusted within hours. Replacement vehicles and crews arrived. Formations reconstituted and moved on. The German army struggled to do the same. As Allied forces pushed across France, the pattern repeated. American armored columns rarely paused long enough for German command structures to regain control. Counterattacks were fragmented. Defensive lines dissolved before they could solidify. Attempts to concentrate armor were detected early and disrupted by artillery and air power, often coordinated through the same radio networks that linked the Shermans at the front. By late summer, the imbalance was unmistakable. The Sherman was no longer evaluated solely by what it could destroy. It was judged by what it enabled: speed, coordination, and relentless pressure. German commanders who once dismissed it as inadequate now faced it everywhere, at all hours, supported by systems they could not reliably disrupt. The war had entered a phase where survival depended less on individual excellence and more on the ability to function within a responsive whole. And in that environment, the advantages of communication compounded daily. But the consequences of this shift extended beyond Normandy and France. They reshaped how the war would be fought to its conclusion, and how armies would think about armored warfare long after the last Sherman rolled to a halt. As Allied forces pressed toward Germany's borders, the lessons of 1944 became embedded in practice. American armored doctrine increasingly assumed constant communication. Radios were no longer described as support equipment in field manuals. They were treated as integral components of combat power. Training emphasized coordination above individual action. Armor advanced with infantry, not because doctrine demanded it, but because radio contact made separation unnecessary. German forces attempted to adapt, but too late and with too little capacity. Industrial shortages, limited radio production, fuel scarcity restricted training. Command structures remained centralized, slowing response even when communication existed. The imbalance widened as the front collapsed eastward, by the final campaigns of the war. American armored units operated with a confidence born of familiarity. Tank commanders expected information to arrive. They expected artillery to respond. They expected neighboring units to coordinate without delay. This expectation shaped behavior: aggressive but calculated, flexible but controlled. Pastora analysis confirmed what the battlefield had already demonstrated. The Sherman was not the most heavily armed or armored tank of the war, but it was among the most effectively integrated. Its radios allowed dispersed units to function as a single organism, absorbing losses without paralysis and exploiting opportunities before they closed. Military historians would later note that German armored doctrine, though tactically brilliant, depended heavily on elite formations and centralized planning. The American approach relied instead on redundancy, standardization, and communication principles better suited to prolonged, large-scale war. The consequences reached far beyond 1945. Post-war armored design across NATO emphasized communication, interoperability, and command systems as much as armor and firepower. The tank was no longer seen as a solitary duelist, but as a platform within a broader network of sensors, shooters, and that shift did not begin with advanced electronics or digital systems. It began with a simple assumption that every tank should be able to speak and be heard. And with that assumption, the Sherman's true legacy came into focus not as a weapon that won by force alone, but as one that changed how force itself was applied. What remained was to understand what that change meant, not just for armies, but for the nature of modern war. The M4 Sherman is often remembered for what it lacked: thicker armor, a heavier gun. the ability to dominate a duel. Those comparisons miss the point. The Sherman was never meant to fight alone, and it rarely did. Its strength did not come from steel, but from connection from the steady flow of information that linked crews, units, and commands into a single, responsive force. In a war defined by speed, uncertainty, and scale, that connection mattered more than any single technical advantage. The Germans built some of the most formidable tanks of the Second World War. They trusted precision, protection, and tactical brilliance. But they entered a kind of warfare where superiority could no longer be measured solely by what stood at the front of the fight. The Americans understood something different. That control of the battlefield came not from seeing the enemy first, but from understanding the situation faster, from allowing junior leaders to act, from accepting that no plan survives contact, but communication survives chaos. The Sherman embodied that philosophy. It burned, it broke, it suffered. Yet it kept moving not because it was invulnerable, but because it was never isolated. Losses were absorbed, decisions were made. Momentum was preserved. When the war ended, tanks would grow heavier, faster, and more lethal. But none would ever again be designed without assuming constant communication. Radios would become inseparable from armor, command inseparable from movement. The Sherman did not win the war by being underestimated. It won by making underestimation irrelevant.